turn on the screen, wouldn't it? There we go. All right, so Chapter 9 is all about transport layer protocols. So basically, we're going to start talking about how things actually get moved around on our network. And we're going to talk about some tools to scan ports. All right, so in this diagram, we're kind of just looking at how ports work. And I know we've talked about ports before. Y'all have seen that list of known ports. You know that, like port 80, for example, you know what that is. What they want to make sure you understand from this slide is when you make a request to a known port number, that device is going to send data back to you on an upper level port that's just a random number. So you send a request to a web server on port 80, and it may send it back to you, for example, on port 47747 or 47748. Port numbers don't always come back on the numbers they're sent on, if that makes sense. So for example, here, a server opens TC port 80 and 143 to run a web and an email server. The client runs a web browser. The browser opens what they call an ephemeral port to connect to the server. Each combination of the source and the destination form a separate connection. The server replies are directed to the ephemeral port. And then a second client can open a port at the same time, but note that it's going to get a different number. So that's how it tells the differences in things. And the unique numbers together is what's called a socket. And if you look at all of that in Wireshark, that is what Wireshark will call a conversation. All right, so I know we've talked about these a little bit, but I don't know how much detail we've gone into, so we'll be sure we do that a little more. TCP and UDP. Remember, TCP is Transmission Control Protocol, and TCP is connection-oriented, so it's the guaranteed delivery. It's called the reliable protocol. And in it, the segments in the header fields have got a sequence number and an acknowledgement. So when you send one, you have this thing called a three-way handshake. And the three-way handshake is how you get the guaranteed delivery, but it's also why it's slower. So first, you've got the client sends a sync. The server sends a sync and acknowledgement, and then the client sends an acknowledgement of the sync acknowledgement. And that's the three-way handshake that takes place. Now, that means, again, we got that guaranteed delivery because we've done all of that. But in the scheme of things, think about it, that's taken time and bandwidth for all of that to happen. Then in the end, you have to tear down the connection, and a teardown is a four-way process. I have a finalization flag, an acknowledgement of it, then a final acknowledgement, and an acknowledgement of the final acknowledgement. I know that sounds like a lot, but that's pretty much what's going on. UDP, on the other hand, is connectionless. We don't guarantee UDP, but UDP is a lot simpler because of that. There's fewer fields in the header. And it is used by protocols that can tolerate lost or out of order packets. You use this for things that you want to get there faster, but that can tolerate some loss. Lots of video is sent this way because of that. DNS, the old DNS system uses this because, again, it's faster. Here is a list of just what they put as common port numbers. This is one of those things that I wish I could tell you what actually to memorize. You're going to get some port numbers on the exam, and I don't know which ones. It varies. Everyone gets different ones. Make sure you pay attention to the questions in exam cram on port numbers. Memorize the ones they're asking you, because since they're the ones that made the test. But be sure you know the common ones that are web servers and email, and like RDP, I know was on mine, 3389, and Telnet and SSH and FTP and things like that. All right, so some tools to scan the network with. Angry IP Scanner is a very good, easy one. I think, have y'all messed with it before?
Yeah.
It's on these computers. I'll show it to y'all in a minute, and it's free. You can go to the internet and download it. Basically, it just scans your network by just doing a ping sweep, and if a system's live, it'll be green, and if it's dead, it'll be red. There are lots of other tools. This is an easy Windows one. One of my favorite tools is called Nmap. And what Nmap does all kinds of things, but it does a deep scan. You can do lots of things with Nmap that are kind of covert. For example, like you can do a scan with Nmap where you don't actually send any data. And now we're kind of jumping into CEH here a little bit, but why might I not want to send any data if I'm doing a scan on a network?
So you don't leave anything behind.
Right.
So
I don't want to set off an IDS IPS. I don't want to set off an intrusion detection system.
Is that a SYN-ACK?
Yeah, if I'm not sending anything, right. In fact, what you can do with Nmap, you can do something called a Christmas tree scan where you send part of that through your window, but you don't finish it. So it never sets off any of the scanners because it doesn't finish it.
Right.
It just sends part of the window to see if it gets a response, but then it doesn't send the response to the response. So it never actually completes a connection.
This is Nmap on Windows, right?
This looks like it might be Nmap on Windows.
ZenMap. So I think you have to have ZenMap on Windows to do Nmap.
ZenMap is actually just a graphical wrapper around Nmap.
Oh.
Nmap itself is a command line tool. In fact, here they're showing, what the actual command would be. ZenMap just runs on top of it. And in fact, the new version of Kali doesn't have ZenMap in it. Without getting into the technicalities of it, the issue is the new version of ZenMap doesn't run on the new version of Python because it was written in Python. So you have to do some magic and install the old version of Python to get it to run. Another tool that's pretty useful is Netstat. And Netstat will give you some statistics about what's going on your machine at one time. And in fact, you can run that, like y'all can run that now. You run a Netstat. That'll show all the connections that are open right now. And you see, I have lots of connections open on this computer.
Oh, this is per the device?
Yeah, that's per device. So see, I have a lot open as well because I'm also recording this, so. Here they're just showing again some stuff with Nmap. If y'all haven't played with Nmap, Nmap is worth learning. Download you a copy of Kali and put it in either VMware or VirtualBox and play some with Nmap. I don't remember the address. If you can't find it when you Google it, I'll put it in the Discord. There is a site Nmap has actually set up on the internet for you to be able to scan freely and not get in any trouble. They built a website for you to scan so you can play around with this or scan your local network all you want. Don't scan your ISP a whole lot. Scan anything you want to in here. Don't scan the campus network, because, well, honestly, nobody will know right now, but don't scan the campus network.
I don't know how long it would take to scan the campus, but
it would take a while. I just playing around with it. I scanned the printer VLAN just to see how long it would take, and it took almost a day.
Yeah.
And I knew there was nothing but printers on it, so
Right.
it wasn't going to hurt anything to scan it just to see. And here they're talking about these scan types again: half open, full connect, UDP, port range. The different scanners take different amounts of time because of what do you want to find. Like if you just want to know if a machine is up, you want to do a ping scan, that's pretty quick. I can just ping, one address to one machine. That doesn't take long. But think about how many ports does each machine potentially have? What's the maximum number of ports a machine can have? Do y'all know that number? Because that might be on the exam if you don't.
It's not the 55,000 or whatever.
65,535.
Oh.
So if I do a full sweep of every possible IP on my network, I have to scan every machine 65,535 times to see if that port is open. So it can take a very, very long time. Even a full sweep of just this lab, knowing how few
Yeah, it
computers
takes
are in
a
here,
while.
would take a full day. Now that being said, if you are a net admin, I strongly encourage you to Nmap your own network because you want to see if something has been stuck on your network that you don't know about.
What are the things called that you put after the command, like the dash S or dash T?
Arguments. The arguments. One thing about Nmap, and this is just for your future reference too, because Linux is that way. Capitalization becomes way more important when you move into the Linux world than it is in the Windows world. For example, one of the best things about Nmap is a -O, which will tell you about the operating system. It'll guess what operating system the remote computer is. But -O and -lowercase o are not the same thing. So you got to remember those arguments are completely different.
For some reason I thought those were switches.
They can be called switches too. Just
Pretty sure that's just what I read.
it's according to who you ask. Seems to me like I remember in the Windows world, they're called switches, and in the Linux world, they're arguments. But I could be backwards or maybe they're interchangeable.
There's a website that has a cheat sheet for the
Nmap, yeah.
commands. There's a bunch.
There's a ton. You could do a whole class on Nmap. One of the CEH books I looked at one time, a whole chapter was just on Nmap. All right, so protocol analyzers. Protocol analyzers, y'all know what these are, Wireshark. Y'all have played with it a little bit, you said. Take some time and learn some stuff about Wireshark. When we get through all of the chapters in here, there's a website I found that's got some sample Wireshark traffic on it. I'm gonna download and let y'all look at because there's just some nice weird traffic out there to see.
I did watch like a 15-minute video about Wireshark.
Wireshark is amazing. There's a whole actually Wireshark.org has their own school. They have a certification in Wireshark because it does so much now. The big key to Wireshark, I'll say, is this. The thing that makes it so popular is it can read a PCAP file. And a PCAP file is the standard file that is written by almost everything when it captures data. If you capture data from one of those Cisco switches, it's a PCAP file. If I capture it from my router, it's a PCAP file. So the fact that I can take that and read it into Wireshark and do things with it is perfect. That means I can capture data off my router and take it into Wireshark and look at the colors and separate it by conversation and all this cool stuff. Something actually you can do with Wireshark that's kind of cool to show. If you are transferring a file with Windows and you're Wiresharking your computer and you started it before you started the file transfer, so you captured the whole thing, you can actually go back in Wireshark and pull the file out of the capture. Because if you did it on your machine, you've got the key. Or if you do FTP, which is notoriously insecure, you can put the file back together out of there and get somebody's username and password. And that is a quick rundown of this chapter. Have y'all got any questions? This one wasn't too bad, huh? I thought we were going to go into that three-way handshake. That must be in the next one. We've got a few minutes then. Y'all said you've not seen Angry IP Scanner? I'm going to show it to you real quick then. Let me, Todd, have you got any other questions before I stop the recording?
No, sir.
Uh-oh, my sound quit again. Hang on. All right, there you go. Have you played around with Angry IP Scanner any?
No, sir. I've used
It's pretty-
Wireshark, but that's it.
Wireshark's pretty cool. Download Angry IP Scanner when you get a little bit of time and mess around with it. If you have any questions, let me know.
Okay.
All right, have a good one.
You too.